Okay, we're up to 32. Here we go. If h of x equals x squared, find the equation for, so we've got our own math problem right here, and it says then sketch the resulting equation. Well, first, we got to realize, inside out, we got to take x minus 1, put it in here. So x minus 1 squared is x minus 1, x minus 1, x squared, outside, inside, last. But we got to multiply that by 2. So we actually get 2x squared minus 4x plus 2. Now, this is the resulting equation that we need to graph. We can see that our parent function is y equals x squared, so that would look something like this. So we know it's a parabola of some sort. Now, how do we graph it? Well, we have to remember our general equation for a parabola looks like this. So, how do we get this to look like this? Well, I'm just going to call this f of x, or y, and I look at this and I think, hey, this is where we have to complete the square. We got to have this to be a 1, so we got to factor out a 2 from this. So we're going to take a 2 out, x squared minus 2x plus space plus 2 plus space. This is completing the square. Take half of that, it's negative 1. Square it is 1, but 1 times 2 is 2. So we've got to balance that with a negative 2. These cancel. So this cleans up to be y equals 2 times x minus 1 squared. So, essentially, we move this one to the right one, the vertex. There is no up or down action, but we have to double vertical stretch, and there it is. Now, we could have just said from the beginning that we move it right one and then vertical stretch it, but I wanted to review the completing the square as well. Okay, last problem on this side. If cosine is 3/7, so if we looked at that, said okay, 3/7, so I'm going to try to draw this with some accuracy. There's my hypotenuse from there. Cosine is adjacent over hypotenuse, and then my adjacent's 3. Now it's saying, what if you took this situation and you went down 270 degrees? Okay, so I drew the drawing just a little bit bigger. This is a little tricky, so stay with me here. So the first thing we're going to do is try to find exactly what theta is. Theta, if cosine is 3/7, we can go second cosine, 3 divided by 7. We get 64, we're going to round a little bit, 64.6. So this is 64.6. Now it says take theta and subtract 270 from it. So we know what theta is, it's 64.6, so watch this now. 64.6 minus 270 gives us negative 205.4. So, if we were to take our spinner, spin it negative 205.4, we know that'd be negative 180. So how much more? So if I added 180 to that, it would give us another negative 25. So watch this now. This is negative 25.4 degrees. Now something interesting about this, which as a reference angle is positive 25.4, but notice this plus this would make 90. So that means that this up here was 25.4 to begin with. This plus this is 90. We know this is 90. So really what this has done is just flip the triangle a little bit, making this our 3, making that our 7. But they want cosine, which means we got to find this side because that's our adjacent side. So we're going to go a squared plus b squared equals c squared. Let's speed this up a little bit. B squared equals 49 minus 9. B squared equals 40. Take the square root of that, and if we broke that down, that'd be square root of 4, square root of 10. or 2 square root of 10 negative. So cosine of this situation, which is what this is painting, would be adjacent negative 2 square root of 10 over the hypotenuse 7. There you go, Unit 5. Solve. Well, we can see that that's law of 3, so we're going to put it right there. So I'm going to rewrite it. This is just minus log. Notice the bases are the same. And I'm going to stop right there because subtraction means division. So that means the same thing as log base 4 16 over 2. Now I'm just going to simplify that to log 4 8. Now this we have a whole nother situation. Again, law of 3 is sitting right there, so I'm going to take that 3, put it there. 2 cubed is 8. So it's plus log base 4 8 equals x. Now let's focus on this. Addition means multiplication, so I'm going to multiply those, and I get log base 4 64 equals x. Now it says to solve it. Well, this is a logarithmic expression or equation, so I'm going to start with this. There's my base. Go here. So 4 to the x power is 64, and I can just look at that and go, hey, 4 cubed is 64, so x is 3. So there's that one. This one's a little different. Notice log base 2, log base 2. We got logs on both sides, which means this stuff has to equal this stuff. So 8 minus 2x has to equal x squared. I'm going to bring all of this over, rearrange it, so I get x squared plus 2x minus 8 equals 0. And I can see that this one happens to be factorable. Plus 4 minus 2 equals 0. So I see that x can be negative 4 or 2. Now this is very dangerous because you cannot have a log with a negative number in this position, no matter what the base is. Because if I take some number, raise it to a power, I will never get a negative, so you got to check these answers. So if I put a negative 4 in here, I get 64, that's okay. If I put a negative 4 in here, I get 8. 8 plus 8 is 16, so that works. Put 2 in. Well, that would be 8 minus 4, which is good. 2, that's good, so they both work. But if you plug these back in and you get a negative something here or here, that would be not a solution. Okay, number 36. We got 2 logs on this side separated by addition, which means we got to multiply this. So it's really 2x plus 1 times x plus 2. So we got to FOIL that out. So 2x squared. I'm going to go outside, inside in one step. 4x plus x is 5x plus 2. And that is the natural log of this stuff. Remember, there's an invisible e here, equals 6. All right. Well, this has, I don't think I intended to have this happen, but so let's just go through this and see what happens. So here's my base exponent, so e to the 6th equals 2x squared plus 5x plus 2. This is a doozy. So I need to take my calculator, turn this on, and I'm going to go e, which is 2.71 raised to the 6th power. I get 396.1. So 396.1 equals 2x squared plus 5x plus 2. I have to deal with this like it's a trinomial because it is, but I think you can see how I didn't intend for this problem to be this difficult. Plus 5x, and that'd be minus 394.1. Now, just to save you a little bit of time, A is 2, B is 5, C is negative 394.1. Put all that into the quadratic formula, and you should be able to get her done. I'm pretty sure I wrote this problem down wrong because it's pretty bizarre. So again, just stuff all of this into the quadratic formula. So that'd be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, which would be 4. Now I'm going to crank this out on my calculator, but I'm not going to burn up this video. Okay, quite the doozy here. So I took all these values, put them in the quadratic formula, crunched them all out. I got down to here. So I got 12.85 and negative 15.35, but remember my hint on the last problem. If you plug these in and you get a negative in this position, it's impossible. So if I put negative 15.35 in here, I definitely get a negative number, so that cancels that as a possible answer. 12.85, definitely a positive, so there's my winner, chicken dinner. Again, I kind of apologize for that one. I think that's a little harder than what you're going to see on the exam, but it's a good problem. All right, number 37. So number 37 piggybacks this sort of a rule. X squared cubed equals x to the 6th. That's just a random example that we're going to use to manipulate this. So, in another way another rule we got to be thinking about is this. When the bases are the same, you're multiplying, you add. We might piggyback this one more than this one. But as you can see, we've got this situation. We've got to write it in this form, a times b to the x. So we're not done until our variable x is our only exponent. So with that in mind, I'm going to rewrite this using this rule right here. I'm going to write it as 3 to the 3x times 3 to the negative 2 power. Now that's a step in the right direction. So now we got to understand a few things. This guy right here is the same thing as 1 over 3 squared, which is 1/9, and we're going to put that in the front. So we got 1/9 times 3 to the 3x. So the question is, how do we go from here to here? So what we're going to do, this is my a right here, so we're good there. We're going to use our finger trick and say, hey, what is 3 cubed? Well, that's 27. So we're going to rewrite this as 1/9 times 27 to the x power. This is the same thing as this, so this would be our final answer. Okay, next problem. Number 38, the first thing that needs to jump out at us is you cannot have, this is a big no-no, can't have a 0 in the denominator, so we look at this and we think to ourselves, aha, x cannot equal negative 6. So this is an inequality problem. We know that the only thing that x cannot equal is negative 6. We've got to keep that in mind. Now we're going to solve this problem. So 2x minus 5 all over x plus 6 less than or equal to 2. Multiply that by x plus 6. Multiply that by x plus 6. These cancel. So 2x minus 5 is less than or equal to 2x. What in the world? That's what I get for making my own problems up. All right, let's make this a 3. All right, so that'd be a 3 here, or else our x's would have canceled. I don't think that's going to happen. So 3x plus 18. I'm going to subtract 2x, subtract 2x, subtract 18, subtract 18, and here we go. So this is a 3x minus 2x, which is x. These cancel. Greater than or equal to negative 23. So this problem is saying x can be greater than or equal to negative 23. Now that means we've got two spaces we need to investigate. Let's try something in here like negative 10 and put it into the original. So I'll try it right in here. So 2 times negative 10 minus 5 all over negative 10 plus 6, is that less than or equal to 3? Well, this is negative 25 all over negative 4, which is 25 fourths. which we can look at this and we say, hey, that's actually 6.25. So is 6.25 less than or equal to 3? No. So now let's test something to this side. And seeing we can plug in a 0, because we know 0 is over here somewhere, that'd be easy to plug in. So we'd get 2 times 0 minus 5 all over 0 plus 6 is less than or equal to 3. So these cancel. So that'd be saying negative 5, 6 is less than or equal to 3. And we say, yes, that's true. So my answer for this problem would be x is greater than or equal to, not equal to, can't equal negative 6. X is greater than, I'm flipping around, negative 6. And there we go.